Okay, so we're starting a new unit that's talking about similarity. So before we can start talking about similar figures, we have to review about ratios and proportions. So if you remember, a ratio will look like this, where you're comparing two numbers. These are the three different ways you can write a ratio. 1 to 2 as a fraction, 1 to 2 with the word, or 1 to 2 with the colon. So what we're going to do on this first problem is we're going to actually write a ratio, and I don't care which form you have it in, so you can decide what's your favorite. So first problem, the bonsai bald cypress tree, don't know how to pronounce that, tree is a small version of a full-size tree. A Florida bald cypress tree called the Senator stands 118 feet tall. What is the ratio of the height of the bonsai to the height of the Senator? So it might be hard to see, but over here you can see that the bonsai tree is 15 inches. So if I were to write a ratio, you have to make sure you write it in the same order. So it says height of the bonsai to height of the Senator. So where you see that word to is where you're going to put in the word to or colon or fraction, whatever. So the bonsai height has to go first. So I would write 15 inches to 108 feet. Now, notice that they have different labels. They always have to be in the same measurement. So since this is in feet, I'm going to have to convert it into inches. So I would go ahead and take 118 times 12 inches, since there's 12 inches in a foot. And so I would end up getting 15 to 1,416. Now, every time that you get a ratio, you're always going to check to see if it reduces, just because it's already written like a fraction, so that should be your kind of hint that you'd have to reduce. So I can divide both of those by 3, so my final answer would be 5 to 472. Okay, pause the video and see if you can come up with the ratio on the got it question. So on the got it question, a bonsai tree is 18 inches wide and stands 2 feet tall. What is the ratio of the width of the bonsai to its height? So the width of the bonsai has to come first to its height, so it comes second. So I would set it up as 18 inches to 2 feet. Has to be in the same label, so I would convert feet into inches, so I took it times 12, and then I would reduce 18 over 24 to 3 over 4, so I divided both of them by 6. Okay, so the next thing we're going to do is we're going to look at a problem where they give you a ratio and you're going to have to set up an equation in order to figure out how many of each type that you have. So take a moment and read through that problem. Okay, so after you've had a moment to read through it, it's asking how many pots of each type of flower should you buy? Well, they give us a ratio of 2 to 3, and they told us that the number of tulip pots are on top, and they told us the number of daffodil pots are on bottom. So what we're going to do is we're going to set 2x and 3x as those different types of flowers, and then I'm going to set up an equation where I'm just going to add those and set it equal to my total. So I'm going to do 2x plus 3x equal to 120 and then solve it. So combine my like terms and get 5x, divide by 5 and get 24. Now what you found is that if I just got 1, it'd be 24, but my ratio says I have 2 of this kind and 3 of that kind. So you're going to have to plug in your x value to actually figure out how many of each kind you have. So if I have 2 times my x, I'm going to take 2 times 24, which is 48. If I have 3 times my x, I'm going to times 3 times 24 and get 72. So the question is asking how many of each type, so I would write down both of them, 48 tulip pots and 72 daffodil pots. Pause the question and see if you can do the got it question. Okay, on the got it question, so you're talking about the measure of two supplementary angles. So I would set it up 1 to 4 would be 1x plus 4x, and then supplementary means they're going to add to 180. So then I would solve. So I would combine like terms, get 5x, divide 180 by 5 and get 36. Then I would plug it back into my ratio amounts that I have. So 1 times 36, 4 times 36. The question is asking for the measures of both of them, so I would write down 36 degrees and 144 degrees. Okay, next part is where you're going to be given some extended ratios. So an extended ratio is just where they're going to start comparing like 3 numbers or more. So far you've just been given 2. So it says the lengths of the sides of a triangle are in the extended ratio, 3 to 5 to 6. The perimeter of the triangle is 98 inches. What's the length of the longest side? So remember, perimeter means I'm adding up all the sides. Since they're giving me a ratio, I'm going to do the exact same thing we did on the previous problem. So I would have to do 3x plus 5x plus 6x coming from my ratio 3, 5, and 6. Then it says my perimeter is 98, so that's how I knew to add them and set it equal to 98. Then we just solve. So I combine like terms, get 14x, divide 98 by 14 and get 7. I'm going to plug back in to find what my different lengths are. So I took 3 times 7 and got 21, 5 times 7 and got 35, 6 times 7 and got 42. Question is asking what is the length of the longest side, so the only answer I would write down is 42 inches. So pay attention to some of these because they will ask for all of them and then sometimes they only ask for one of them. Alright, pause the video and go ahead and do the got it question. Alright, on the got it question, my ratio would set it up as 4x plus 7x plus 9x and then equaling my perimeter, which is 60. Combine my like terms, I got 20. Divide 60 by 20 and get 3. Then I put in 3 for each of my ratios. The question is asking for all of the lengths, so I would list them all. So 12 centimeters, 21 centimeters, 27 centimeters. Every time they give you a label, make sure that you're labeling your answer since it is a story problem. Okay, last piece here is where we're actually going to solve some proportions. So this is taking you back to your Algebra 1 days. So if they give you the proportion 6 is to x as 5 is to 4. You probably use the cross product property, which means that you're going to cross multiply and set up an equation. So you're going to go ahead and do 6 times 4, which is 24, and do 5 times x, which is 5x, and then you solve that equation by dividing by 5. So my answer ends up being x equaling 4.8 or 4 4/5 if you like writing it as a fraction. I would do the same thing on letter B. The only difference on letter B is it becomes a little bit more in depth. So some of you on letter A may be used to just cross multiply and divide. That does work there because it's a very simple problem. But once you start getting to like B, where you have an expression in there, you have to set up an equation in order to solve it. So I would cross multiply to set up my equation. So I would do 3 times 1 plus 4. And notice I put parentheses around it so I times both of them, equaling the other diagonal, which would be 9 times y. And then I would solve. So I would distribute and get 3y plus 12 on this left side. And then I would need to combine like terms or cross my equal sign. So I would have to do the opposite. So I'm minusing 3y from 9y. I get 12 equaling 6y, and then I divide by 6, so I get y equals 2. So I want you to pause the video and do the last two on the got it question. Okay, on the got it question, if I cross multiply, I get 9 times 14, which is 126. I would come back and divide 126 by 2, and I would get 63. On the second one, you will need to set up an equation in order to solve it. So I do my cross product. So 15 times n is 15m. 3 times the quantity m plus 1 would be my other diagonal. So then I would distribute and get 3m plus 3. I would need to subtract 3m from 15. Get 12m equaling 3, and then make sure you divide correctly here. You're going to want to divide by 12 because I'm getting m by itself. So m is a fourth or 0.25. So this first lesson is just getting you set up to do some proportions and ratios. So it's just kind of a review, if you will. If you still have questions, let me know. Otherwise, go ahead and start your assignment.